Hi, today we are going to talk about even and odd functions. Let's go ahead and jump into example 1, but we don't call them examples. We call them fun problems. Who typed this? It was me. All right. So fun problem number 1 reads, determine whether each function is even, odd, or neither. So we are given 3 functions. Well, we will attack them one at a time. Let's go ahead look at problem A. So we are given a function and we are asked to determine if the function is even, odd, or neither. So if I am asked to make that call, it will be nice if I know how to determine that. So looking at the top of the page, let's go ahead and look at our first point. So it reads, f is an even function if f of negative x equals f of x. Now, how can I tell if f is an odd function? So f is an odd function if f of negative x equals negative f of x. That's like a lot of words for me, so let me write it a little bit different. So the punchline is when you are asked to determine if a function is even, odd, or neither, what I need you to do is find f of negative x. So you are going to substitute a negative x for your input. And then you are going to see if, when you find f of negative x, if you get f of x. So pretty much if you get back the original function, then that tells you that the function is even. However, when you find f of negative x and you don't get back the original function itself, but you get its opposite, then that will tell you that the function is odd. From a visual perspective, what does that mean? From a visual perspective, if the function is even, then the graph is symmetric with respect to the y-axis. So let me go ahead, take out my special effects. I'm a little old school, so you know I'm not high tech. So I made this for you. So if a function is symmetric with respect to the y-axis, so this is the y-axis, someone forgot to put y. I guess I can fold this about this axis, and in this case the right side should look like the left side. Bam, special effect. And if I take the left side and fold it about the y-axis, how would it look like? You guessed it, like the other side. Boom, so there you go. Okay, now what about odd functions? So odd functions are not symmetric about the y-axis. The graph of an odd function is actually symmetric with respect to the origin. It's also known as point symmetry. So you guessed it, I'm going to take out another special effect. Alright, so the graph of an odd function is symmetric with respect to the origin. So pretty much, let me go ahead, take my finger or my trusty pen, and then I'm going to rotate 180 degrees. So this is the top, this is the bottom, and if I put my finger here and rotate it 180 degrees, the graph should look the same. I practiced this before the video, but you know how things go, they don't always work out. So let me go ahead and put my finger here about the origin. I should rotate 180, and if the book didn't lie to me, I should get back my original graph. Oops, this thing is moving. And just like that, we get back our original graph. Okay, that was a lot of wording. Let's go straight to example fun problem 1. Okay, so problem A, we have f of x is equal to x to the 5th minus x, and the question reads, is the function even, odd, or neither? Okay, we are always going to start by finding f of negative x. So if I want to find f of negative x, we are going to substitute a negative x for the input, or x. So we have f of negative x equals, we have x, and we're going to swap it out for negative x. We're going to raise it to the 5th power, minus another x, which we are swapping out for negative x. And we are going to take our time and see what this simplifies to, and then we'll see if we either got back the original function or if we got the opposite, or neither what. Negative x raised to the 5th power gives us negative x to the 5th power. A little flashback when it comes to powers of negative factors. So if you have a negative factor and you raise it to an even power, then your result will be positive. But if you have a negative factor and you raise it to an odd power, then your result will be negative. So coming back to negative x raised to the 5th power, we have 5 factors of negative x, so we'll have x times x times x times x times x. Yes, beautiful fingers. So that gives us 5 factors of x. So we know that there's an x to the 5th involved. But now the question is my result going to be positive or is my result going to be negative? Because we have a negative factor that's raised to an odd power, then our result is going to be negative. So this is why we have our answer is negative. Moving forward, opposite of negative x is positive x, or bad math, 2 negatives make a positive. So now the question that I'm going to ask myself is this: did I get back the original function or did I get its opposite? Well, last time I checked, negative x to the 5th plus x looks nothing like this, so we didn't get back the original function, so the function is not even. Now the question is, did we get its opposite? And I'm going to illustrate this in 2 ways. We can just look at each term and then see if they are indeed opposites. Positive x to the 5th, negative x to the 5th, opposite. Negative x, positive x, opposite. So since they're opposites all the way, then I guess we can say that the function is odd. However, this is a lot for me to digest. I'm going to do it a little bit different. Oh, we box our answers. We don't underline them. Oh, all right. So in this case, I'm going to go ahead factor out a negative sign, so it'll be a little bit easier for me if I really did get the opposite. So if we factor out a negative 1, negative x to the 5th over negative 1 will give us x to the 5th. Positive x over negative 1 will give us negative x. So when I factor out a negative 1, it's easier for me to see if I really did get the opposite. The function, or f of x, equals x to the 5th minus x. And the question is, do I see another x to the 5th minus x? Oh, I sure do. Okay, so we get back the original function. When we bring down the negative sign, we get back the original function, but it's actually its opposite. Too many words because I'm a little bit nervous. So the moral of the story is this: when we find f of negative x, we get the opposite of the function. And if we get the opposite of the function, then the function is odd. But I already wrote down the answer. There's no need for me to write it again. Let's go ahead and knock out problem B for the almost grand finale. So problem B, we have h of x is equal to x to the 4th minus x squared. And same question, is the function odd, even, or neither? And we always start by finding f of negative x. In this case, I got a little tired of using the same name, so we spiced it up and changed the name to f. So we are going to find h of negative x and then see if we get back the original function or if we get its opposite. So that will give us, substitute a negative x for the input of x. So we have x, which we swap out for negative x. We raise it to the 4th power minus another x, which we're swapping out for negative x, raised to the 2nd power. Negative x to the 4th power means that we have 4 factors of negative x. Yes, lovely fingers. So that will give us some form of x to the 4th. What I'm questioning is it going to be positive or negative? So flashback. If we have a negative factor and raise it to an even power, the result will be positive. Even power, so result is positive. Minus square of negative x gives us x squared for the same speech that we just said before. So the question is this bad boy odd, even, or neither? So I want to know, did we get back the original function? We sure did. The original function reads h of x is equal to x to the 4th minus x squared. And that's precisely what we got. So looks like this bad boy is even. Oh, that was exhausting. All right, for the grand finale before we take a quick break. So problem C, we have f of x is equal to x to the 5th minus 3. And then same speech. Is this function even, odd, or neither? So let's go ahead find f of negative x. So we will substitute a negative x for the input x. So in English, substitute a negative x wherever you see the variable x. So we have an x, which we are swapping out for negative x. raising it to the 5th power, less 3. Negative x to the 5th power means we have 5 factors of negative x. Remember, lovely fingers. So that leaves us with 5 factors of x. But the question is the result going to be positive or negative? So remember, negative factor, odd power, your result is negative. And then we bring down, oops, we have no time to make another video. This is just going to be part of the blooper. Okay, so that will give us negative x negative x to the 5th less 3. So the question is, did we bounce where am I? So the question is, did we bounce back or did we get the opposite? So we have x to the 5th minus 3. That does not look like x to the 5th minus 3. So we didn't get the same thing. So the function is not even. That makes me sad because that's easier for me to check. So now the question is the function odd? So I don't know. Are the functions opposite? So we have positive x to the 5th, negative x to the 5th. Yeah, they're opposites. Negative 3. Oh, this is not positive 3. Okay, these are not opposites. So to answer my question, did we get back the original function? No, this is why we're not even. Are the functions opposite? No, this is why the function is not odd. So if you're not odd and you're not even, then I guess the function is neither odd or even. Okay guys, that is my time. Thank you.